Welcome back, and here we are still working on determination of the true length and true inclinations of a line in space. Here we have another question, and we are going to make use of rotation method, and after this method, we are going to have another video that we are going to use the second method known as trapezoid method. Let me read the question. I'll read the question twice, then we go on and look at how we can determine the true length and true inclinations of this given line in space. The question says a straight line PQ has its end P 15 millimeters above the HP, that is horizontal plane, and 60 millimeters in front of the VP, that is the vertical plane. The end Q is 45 millimeters above the HP and 10 millimeters in front of the VP. If the end projectors of the line are 60 millimeters apart, draw its projections, determine the true length and true inclinations of the line with the principal planes. I'll take the question again. A straight line PQ has its end P 15 millimeters above the HP and 60 millimeters in front of the VP. The end Q is 45 millimeters above the HP and 10 millimeters in front of the VP. If the end projectors of the line are 60 millimeters apart, draw its projections, determine the true length and true inclinations of the line with the principal planes. That is the question. Now, let's go and see how this problem can be solved. The first thing that you have to do is to draw a horizontal line. Draw horizontal line XY. So here we are going to indicate this is end X of the line, and this is end Y of the line. And then let's indicate the planes. Here is the vertical plane, okay? And here is the horizontal plane, HP. All right, now the next thing that you are going to do is that you come to move away from the end of the line and draw a vertical line like this. Now, this point where the vertical line touches this XY line, let's call it point O here. Then, since we are told that the end projectors of the line are 60 millimeters apart, on this XY line from this point O, take 60 millimeters to this side. So this is 60 millimeters here. And this point, I'm going to call it point O prime. Now, we are going to draw a vertical line through this point O prime. Draw a vertical line through this point O prime. So we have this vertical line like this. All right, so having done that, the next thing that we are going to do is to take the measurements of the end P of the line. Now, we are told that the end P of the line is 15 millimeters above the horizontal plane. 15 millimeters above the horizontal plane. So that's 15 millimeters that is above the horizontal plane. That is end P 15 millimeters above the horizontal plane. So from this XY line at point O, take 15 millimeters up into the vertical plane. When the point is at a particular distance above the horizontal plane, you take that measurement up the XY line into the vertical plane. So this is end P of the line. I will call this P prime. Then we also told that this same end P is 60 millimeters in front of the vertical plane. 60 millimeters in front of the vertical plane. So when the point or the end of the line is at a particular distance in front of the vertical plane, so that distance will be taken down the XY line into the horizontal plane. So this is what I mean. So we are going to take a measurement of 60 millimeters from this point O down the XY line on the horizontal plane. So that's 60 millimeters. So here we have this point is point P or the end P of the line, 60 millimeters in front of the vertical plane. And as I said, that will be taken down the XY line into the horizontal plane. All right, so now let's go to the next part of the line, as we are told that the end Q is 45 millimeters above the horizontal plane, above the HP, 45 millimeters above the horizontal plane. So we are going to take 45 millimeters from this point O prime, 45 millimeters up the XY line into the vertical plane, up the XY line into the vertical plane. If the point is above the HP, we take that distance up the XY line into the vertical plane. So this point now is point Q prime. So here we have this point Q prime. And also, we're also told that this same end Q is 10 millimeters in front of the vertical plane. 10 millimeters in front of the vertical plane. So from this point O prime, you take 10 millimeters down the horizontal plane into down the XY line into the horizontal plane, down the XY line into the horizontal plane as we have it here. So this point is point Q as we have it here. All right, so with what we have done here, as we have taken the distances, the next thing that we are going to do is to draw the projections of the line as we are told in the question. So projections of the line, we are joining this point P prime and Q prime together like this. And this line P prime Q prime is the front elevation or front view of the line. Then we are also going to join point P and Q together with a straight line. So we join these 2 points together with a straight line. And this line PQ is the top view or plan of the line. So we have drawn the projections or line as we are told in the question. Now, let's go and look at how we can determine the true length and true inclinations of this line to the principal planes as we are told in the question. Now, the next thing that we are going to do is that we are going to draw a horizontal line from this point, okay? And this horizontal line that we are going to have here, so we draw the horizontal line like this towards this point, and then we are going to draw a locus line at this point Q here. So locus line is drawn with thin long chain line as we have it here like this, and then we come up here to point P prime here. We draw a horizontal line to this side, okay, and then we come up to point Q prime. We draw the same locus line with thin long chain line as we have it here like this, okay. So here we have this. So this line, I need to connect these 2 lines together, okay. So we draw this. All right, so we have this now. Now, for what we have done here, so the next thing that we are going to do is this. Very simple. We want to determine the true length, okay. So we are using rotation method. So we take the compass. So you put the pinpoint of the compass here at this point P prime here, and we extend it to Q prime. So we want to determine the true length of the line. So we are using rotation method. Put the pinpoint of the compass at this point P prime and extend the pen point to point Q. Then you draw an arc like this. You rotate the compass. So you draw an arc to touch this horizontal line. So where it touches this horizontal line, I'm going to call this point, I'm going to call it point Q2. So Q2. So Q2 prime, okay. Now, then the next thing that I'm going to do is that we are going to draw a vertical line. Draw a vertical line from this point Q2 prime to touch the locus line. So we draw a vertical line from here to touch the locus line. So touching the locus line here, okay. Then this point here, I'm going to call it point Q. So Q1, so Q1 prime, okay? Then I'm going to join these 2 points together. So we join these 2 points together, point P and point Q1 prime. So we join them together like this with a straight line, okay? So this line is the true length in the horizontal plane. So this line is the true length here in the horizontal plane. So we write TL here. So this is the true length here in the horizontal plane. Now let's determine the true length of the line in the vertical plane. True length of the line in the vertical plane. So we put the pinpoint of the compass here at this point P, and we extend the pen point to point Q here. Okay, we extend to point Q here in the horizontal plane, and then we rotate by drawing an arc like this to touch this line. Okay, all right, so then from this point here, so this point, I will call it point Q1. So this is point Q1. The next thing that we are going to do is that we are going to draw a vertical line here from this point. So draw a vertical line from this point Q1. So going up to touch the locus line here, okay? So this point, we are going to call it point Q2. So this is point Q2. So we have this. So now, so we are going to join points P prime and Q2 together to get the true length of the line here in the vertical plane. So it goes like this. All right, so here we have the true length of the line in the vertical plane. So this is the true length of the line in the vertical plane. So we have this to be the true length of the line in the vertical plane. So we are done with how we can determine the true length. Now let's go and determine the true inclination of the line. Or before that, let's take the measurement of the line that we call the true length, that is PQ1 prime in the horizontal plane and P prime Q2 in the vertical plane. Okay, so this should be Q2. Okay, that's Q2 as we have here. Okay, so now let's take the measurement. So P1 or P prime and Q2. So what is the distance? So this distance, as I can see here, is around 85 millimeters, about 85 millimeters. So I'll just leave it as 85 millimeters. So let's write it down. So in the vertical plane, so we have the true length. So true length. So P prime Q2, P prime Q2, so is equal to 85, then plus or minus 1, 85 plus or minus 1. So what about here in the horizontal plane? So what is the true length in the horizontal plane? So we also take this distance. So here we also have this distance to be around 85 millimeters. As you can see here, 85 millimeters. So we also write it down. So we also have what? Q1 prime, so is equal to, so we have what? We have this to be equal to the true length. Okay, so true length, so is equal to 85, so plus or minus 1. So in the horizontal plane, so we are done with the determination of the true length. Now, so let's determine the true inclinations to the vertical plane and to the horizontal plane. Now, so I'm going to make an arc here. So between this horizontal line and this line P prime Q2, so I make an arc here like this. Okay, so this angle here, I will call it angle theta. So this is angle theta, and theta is equal to, okay, then let's also make an arc here. So by making an arc between this horizontal line and this line PQ1 prime, so I'll call this angle here, I'll call it angle alpha, as we have here. So angle alpha, so is equal to, okay, so let's take the measurement of the angle, make use of our protractor. So if I set the protractor here at point P, okay, so what I can see here, so this angle, as I can see here, is angle 21 degree. So this is 21 degree, as I can see it here. So that means angle theta is equal to 21 degree. So this is 21 degree. And this angle here is the inclination to the horizontal plane. This is inclination to the horizontal plane. So let's take note of that. This is inclination to the horizontal plane, okay? So that our true inclination to the horizontal plane, true inclination to the horizontal plane, and then so true inclination to the vertical plane, that is angle alpha. So by setting my protractor like this, okay, so I have this angle to be angle 36 degree, so 36 degree. So true inclination to the vertical plane, I have this to be 36 degrees. So this is 36 degree. So that is, so we have this true inclination to the VP. So is 36 degree as we have it here. So using rotation method. So we have drawn the projection of the line as we are asked to do that. Then we have also determined the true length and also true inclinations to the principal planes, that is the vertical plane and the horizontal plane. It's as simple as I've done it here. All you have to do is to practice. Let's look at the next method in the next video, that is trapezoid method. Thank you and God bless you.